This lecture video. In this video, I am going to explain problems on optical fibers, which comes under module number 3 of engineering physics, prescribed by video. Now let us go to the problems. The angle of acceptance of an optical fiber kept in air is 30 degrees. Find the angle of acceptance with the fiber in a medium of refractive index 4 by 3. So here theta naught is given as 30 degrees, and then the refractive index of the media is 1.333. So n naught is equal to 1 for air. So the surrounding media, if it is air, the n naught value is 1, and if the surrounding media is given as 4 by 3 refractive index, so it will be 1.333. So n naught dash sin theta naught dash is equal to n naught sin theta naught. So that will be equal to square root of n1 square minus n2 square. That is theta naught dash is equal to sin inverse of n0 sin theta naught divided by n naught dash. So substitute the values of n0 and then theta naught and n0 dash. Then on simplification, the value of theta naught dash is observed to be 22.03 degrees. Next problem. The refractive index of the core and padding of a step index fiber are 1.45 and 1.40 respectively, and its core diameter is 45 micrometer. Calculate the refractive index change and numerical aperture. So refractive index change and numerical aperture that we have to calculate. The given data is n1 is equal to 1.45 and n2 is 1.4, d is 45 micrometer, and n0 is equal to 1. So what is delta and then what is numerical aperture? So delta del or del is equal to n1 minus n2 by n1. So substitute the value of n1 and d here, that is 1.45 minus 1.4 divided by 1.45, and on simplification the value of del is found to be 0.0345, and numerical aperture is equal to square root of n1 square minus n2 square divided by n0, that is equal to square root of 1.45 square minus 1.4 square divided by 1. So on simplification, the value of Na is 0.3775. So this is what the solution for the given problem. An optical signal propagating in a fiber retains 85% of input power after traveling a distance of 500 meter in the fiber. Calculate the attenuation coefficient. That is attenuation coefficient alpha we have to calculate. So power output is 85% of input power, that is equal to 0.85 of Pi, and then length of the fiber is 500 meter or 0.5 kilometer. So we know that the attenuation coefficient alpha is equal to minus 10 by L logarithm of P naught by Pi. So substitute the value of L and then P naught, then it will be written as minus 10 by 0.5 logarithm of 0.85 Pi by Pi. So Pi cancels, and on simplification we get minus 10 by 0.5 into logarithm of 0.85. So finally the value of alpha is found to be 1.412 dB per kilometer. This is what the solution for the given problem. That is the attenuation coefficient alpha is 1.412 dB per kilometer. The attenuation of light in an optical fiber is 2 dB per kilometer. What fraction of its intensity remains after 2 km and 5 km? So here the value of alpha is 2 dB per kilometer, and the value of P naught by Pi at L is written as 10 to the power of minus alpha L by 10. And hence we can write P naught by Pi at L is equal to 2 km as 10 to the power of minus alpha L by 10, or 10 to the power of minus 2 into 2 by 10. That is on simplification it will be around 0.3981. So when the value of L at 2 km, the value of P naught by Pi is found to be 0.3981, and when the value of L is equal to 5 km, the value of P naught by Pi is calculated as 10 to the power of minus alpha L by 10. that is equal to 10 to the power minus 2 into 5 by 10, that is equal to 0.1. This is what the solution for this problem. The refractive index of the core and cladding of a step index optical fiber are 1.45 and 1.40 respectively, and its core diameter is 45 micrometer. Calculate its fractional refractive index change and numerical aperture. So N1 is given as 1.45, N2 is 1.4, D is 45 micrometer. So what is del and numerical aperture? We know that del is equal to N1 minus N2 by N1, that is 1.45 minus 1.4 divided by 1.45. So the simplified value of del is 0.0345. We know numerical aperture is equal to square root of N1 square minus N2 square by N0, that is equal to square root of 1.45 whole square minus 1.4 square divided by 1. So on simplification, the value of numerical aperture is found to be 0.3775. So this is what the solution for this problem. Calculate the numerical aperture and angle of acceptance of an optical fiber having refractive index 1.563 and 1.498 for core and cladding respectively. Here N1 is 1.563, N2 is 1.498, so N0 value is 1, and what is the value of numerical aperture and theta naught? Numerical aperture is given as square root of N1 square minus N2 square by N0, that is equal to square root of 1.563 square minus 1.498 square divided by 1. So the value of Na is simplified as 0.4461. And we know that theta naught is equal to sine inverse of numerical aperture, that is equal to sine inverse of 0.4461. So the value of theta naught is written as or calculated as 26.49 degrees. A glass clad fiber is made with the core glass of refractive index 1.5 and cladding is doped to give a fractional index difference of 0.0005. Determine the cladding index and numerical aperture. So here N1 is 1.5, del is 0.0005 and N0 is 1 and N2 is we have to calculate and Na we have to calculate. So we know that del is nothing but N1 minus N2 by N1, and therefore N2 can be written as N1 minus del N1, that is equal to 1.5 minus 0.005 into 1.5. So on simplification, the value is observed to be 1.499. So this is what the solution for this problem, and the numerical aperture is written as square root of N1 square minus N2 square by N0, that is equal to square root of 1.5 square minus 1.499 square divided by 1. So the value of Na is calculated as 0.0474 or which is approximately 0.054. Consider a slab waveguide made up of ALGAS having refractive index of core and clad, that is 3.6 and 3.55 respectively. Find how many modes can propagate in this waveguide if D is equal to 5 lambda. So the value of N1 is 3.6, N2 is 3.55 and D is 5 into lambda, that is 45 10 to the power minus 6 meter, and N0 is 1. So what is the value of V and N here? So we know that V is equal to pi d by lambda into square root of N1 square minus N2 square by N0. So substitute the value of N1, N2, N0 and D and lambda here. On simplification, the value of V is going to be 9.39, and further number of modes is equal to V square by 2, that is equal to 9.39 square by 2, that is equal to 44.1 modes, which is approximately equal to 44 modes. The refractive index of core and cladding are 1.50 and 1.48 respectively in an optical fiber. Find the numerical aperture and angle of acceptance. So N1 is 1.5, N2 is 1.48, N0 is 1. So what is Na and theta naught? We know that Na is equal to square root of N1 square minus N2 square by N0. Substitute the value of N1 and N2. Therefore, Na is equal to square root of 1.5 minus 1.5 square minus 1.48 square divided by 1. So after simplification, the value of Na is found to be 0.2441, and we know that sin theta naught is equal to numerical aperture. Therefore, theta naught is written as sin inverse of numerical aperture. That's equal to sin inverse of 0.2441. On simplification, the value of theta naught, that is the acceptance angle, is found to be 14.13 degrees. So this is what the solution for the given problem. Thank you.